one last relatively small piece of ionic nomenclature to square away, and that's going to be our hydrated compounds. This is a pretty small but a pretty important part of chemistry. You'll use hydrates in our lab courses, and you probably even use a hydrate at home, as Epsom salts are the hydrated form of magnesium sulfate. So, we'll name them. I'm sure at this point you're asking yourself what could be so different about hydrates that they need their own naming rule. Hydrates are ionic compounds, either type 1 or type 2 compounds, that have water molecules trapped inside of their crystal structures. The waters get trapped as the ions in the salt are coming together. There are always the same amount of waters that get trapped in each of our different hydrates. For instance, there's 5 water molecules trapped per formula unit of copper 2 sulfate. Never 4 and never 6, always 5. This consistency means that we can give them their own naming scheme. The fact that we can drive off these waters and change the properties of the compound is really why we need to name them differently though. Take the copper compound I just mentioned, which was copper 2 sulfate, for instance. When the waters I mentioned are trapped alongside the copper 2 cations and the sulfate anions, the compound will be blue and crystalline and have an almost wet appearance. The blue solid in the watch glass on the left here is copper 2 sulfate pentahydrate. However, if you heat this blue solid, the waters will be driven off, changing our chemical formula. And it doesn't even take that much work. For this particular hydrate, you can just hold the sample over a Bunsen burner and the waters will evaporate. So you have driven them off when you end up with a great amorphous solid, which is shown on the watch glass on the right here. Obviously, if the compounds will have different appearances, they could behave differently chemically as well. So we need to differentiate the hydrated and the anhydrous compounds with both of our formulas, which I've done here, and also with our nomenclature. So how do we do that? Well, you'll first name the salt just like we've been doing. This means that you'll need to determine whether you're working with main group cations or transitional metal ones so that you use the correct rules when naming your compound. But this part hasn't changed from what you learned for the rest of the section. Just name the compound salt part like any other ionic compound that you've seen. Lastly, you'll add a third part to the name to tell the chemist how many water molecules are trapped. You'll use the same Greek prefixes that we saw in the molecular nomenclature section to denote the number, and you'll put the word hydrate to indicate that they are water molecules. This means that the copper 2 sulfate that we saw on the last slide would be named copper 2 sulfate pentahydrate. One piece of the name for the cation, one piece for the anion, and one piece for the waters.